Hello students, welcome to the series of organic chemistry. Dear students, we have been learning organic chemistry chapters. Till now, we have completed hydrocarbons, alkanes, alkenes, alkynes and aromatic compounds, their preparation and chemical and physical properties, followed by haloalkanes and haloarenes, then alcohols, phenols and ethers. Recently, we have completed preparation and chemical properties of aldehydes, ketones and carboxylic acids. Dear students, today we are going to learn exercises from chapter 2, that is aldehydes, ketones and carboxylic acids. Let us see the exercises. These are very important students to solve with respect to your board exams as well as with respect to entrance exams like JEE Mains, NEET and IIT JAM. So most of the times questions are expected from your exercises. Let us see the questions. Yes students, let us see questions. What is meant by the following terms? Give an example of the reaction in each case. They have given cyanohydrin, acetal, semicarbazone, aldol, hemiacetal, oxime, ketol, imine, 2,4-DNP derivative, Schiff bases. All these terminology is related to aldehydes and ketones. What is cyanohydrin? Addition of hydrogen cyanide to aldehydes is known as hydrocyanation. So aldehydes upon addition reaction, as I said, aldehydes and ketones always undergoes nucleophilic addition reaction, whereas alkenes undergoes electrophilic addition reaction. In this case, aldehyde is going to be added to the nucleophile cyanide nucleophile. This hydrogen cyanide, where cyanide nucleophile is a weak nucleophile, so to activate or make it strong nucleophile, add sodium hydroxide. This sodium hydroxide makes hydrogen cyanide as strong nucleophile, where this nucleophile adds to carbonyl carbon and the obtained oxonium ion, oxide ion is going to take up proton to give hydrocyanation product. These are very important synthetic organic compounds where you are directly making one carbon extra, or you are making aldehydes to one carbon extra aldehydes or ketones. Yes, from aldehydes you are going to prepare one carbon homologue of aldehydes by hydrocyanation. So this cyanide you can make it amide, acid, ester, or you can make it whatever the way you want. So you are extending the homologue of one carbon. This is how hydrocyanation is, addition of hydrogen cyanide to carbonyl compounds. In this reaction, as usual, aldehydes reacts very fast compared to ketones, because ketones are hindered. This carbonyl carbon is hindered with respect to, because of these two alkyl groups or aryl groups. So approach of nucleophile onto this carbon is not that easy when compared to aldehydes. In aldehydes, one side is alkyl or aryl group will be there. However, other side is a small atom where hydrogen is ready to accept or allow nucleophile, incoming nucleophile. That is why aldehydes undergoes very easily nucleophilic addition when compared to ketones. Then what? Acetal, hemiacetal and ketol. Dear students, so addition of alcohols to aldehydes gives hemiacetal. This hemiacetal further reacts with another mole of alcohol to give acetal. So aldehydes upon reaction with 2 moles of alcohols gives acetal. So this reaction has to be done in dry HCl. If not, it is going to be backward reaction, that is hydrolysis of acetal takes place. Acetal is a compound where upon reaction with aldehydes, upon reaction with 2 moles of alcohols, undergoes nucleophilic addition. This time nucleophile is the hydroxy compound, this is alcohol compound, it adds to carbon. Then the another molecule of hydroxy compound is going to form this acetal. This acetal formation is very important, students. So this acetal formation forms via hemiacetal. So this hemiacetal followed by acetal formation is important with respect to when you want to protect this aldehyde group from other reactions where you have to work on some other functional group during your reaction synthetic mechanism. You can use it as protection and deprotection method. Yes, students. So when you take aldehyde, the acetal you are going to get. In place of aldehyde, if you take ketone, the obtained acetal is known as ketol. Since the acetal is coming from ketone, it is named as ketol. So the cyclic ketols are strong enough to withstand during the reaction of other reaction conditions. So this hydroxy ethylene glycol, since it is having two hydroxy groups, so there is no need to add 2 moles of alcohols. Using 1 mole of alcohol like ethylene glycol, you are going to get cyclic ketol. This cyclic ketol. So the ketol obtained from ketone is known as ketol, or the acetal obtained from ketone is known as ketol, and the acetal obtained from aldehydes is known as acetal. Semicarbazone, oxime, imine, 2,4-DNP derivative, shift bases. These are all amine derivatives of aldehydes and ketones. Dear students, so I have explained in detail with mechanism during the class of aldehydes and ketones. If you are not yet watched, so please watch the video, which is going to be, the link is available below of this video description. Yes, so aldehydes are ketones upon condensation with this ammonia. For example, here if it is hydrogen, it is going to lose water molecule to give imine, right? So if I use water molecule, I am going to get imine. If I use alkyl or aryl amine, it is going to lose water to give shift base. The imine, whatever the imine you are going to get, alkyl or aryl substituted imine is known as shift base. So imine is nothing but a shift base, right? So here oxime, hydroxy oxime is going to be obtained when I treat hydroxylamine with aldehydes or ketone. Carbonyl compounds upon treatment with hydroxylamine gives oxime. This oxime finds very important synthetic utility during the rearrangement name reactions. So what is the name reaction? Schmidt rearrangement. Hydroxylamine oximes undergoes Schmidt rearrangement. Yes, so when I treat carbonyl compounds with hydrazine, I am going to get hydrazone. If the hydrazine is phenyl hydrazine, then I am going to get phenyl hydrazone. When it comes to 2,4-dinitrophenyl hydrazine, so this is phenyl hydrazine, simple phenyl hydrazine. If I treat this carbonyl compound with 2,4-dinitrophenyl hydrazine, it is one of the tests to identify carbonyl compounds where it is going to form crystalline solids of yellow, orange, red. Yes, so 2,4-DNP test is one of the tests conducted for the identification of carbonyl compounds. So once if a given mixture is forming this crystalline solid with 2,4-DNP, it is nothing but carbonyl compound is present in your taken mixture. And when it comes to semicarbazone, so semicarbazone is very important, students, where you are going to use semicarbazine. Semicarbazine is urea derivative. So this is urea. So in this case you are going to get a question like this. So the options may include this side amine making imine, but this amine is not going to form imine because this lone pair of electrons are resonantly stabilized in resonance with this carbonyl compound, where this oxygen takes up this lone pair or bonded lone pair to form enolization, imine all form, right? So this amine is going to form semicarbazone or imine like compound. So remaining urea is going to be intact, right? It is not like this compound is not going to be like this. Nitrogen. So you may get this option also in your exams, but this is not the compound. Sorry, here one hydrogen and NH2. Yes, so this is not going to be the correct option. So it is going to react with this side amine and to give this semi-carbazone structure. That is why very important. So please remember this, students. So semi-carbazone you are going to get this way. Next, aldol. Aldol reaction is very important synthetic reaction where you are going to form CC single bond or CC double bond. So aldol reaction is the reaction between two aldehydes having alpha hydrogen. One of the aldehyde or ketone having alpha hydrogen in presence of dilute base or sodium hydroxide, in this case sodium hydroxide, dilute base or mild base. You can get it as KOH, dilute KOH, mild KOH, dilute NaOH, dilute KOH, or barium hydroxide. If you use ketones, barium hydroxide has to be used. Yes, so barium hydroxide ketones, as I said in first slide, so ketones are slow in reaction conditions because it is not going to allow the incoming nucleophile. So use of barium hydroxide when you take ketones, it is going to go fast, right? So aldol reaction is a reaction between two aldehydes having at least one hydrogen, alpha hydrogen in presence of base, gives CC bond formation beta hydroxy aldehydes. This is beta hydroxy aldehyde. What is the step? First step, aldehyde, this hydrogen, alpha hydrogen will be abstracted by base, dilute base. If you use concentrated base, it is going to be Cannizzaro reaction. Yes, students. So dilute base abstract this proton, and this proton, after abstraction of this proton, it forms carbanion. This carbanion is going to act as nucleophile. Now this nucleophile attacks or adds to another carbonyl compound or another molecule of aldehyde. This case, if it is methyl, same aldehyde, it is going to be the same compound, right? If it is phenyl, so cross aldol reaction. If other molecule, it is going to be cross aldol. Anyhow, this is acetaldehyde, what you have taken, acetaldehyde, this carbanion what is formed is going to be attack onto this carbon and it is going to form oxygen anion. This takes a proton from water, or upon during the workup it takes a proton to give beta hydroxy compounds. So this reaction will be conducted at room temperature. Most of the times it is going to be conducted room temperature or below the room temperature. However, you can isolate this beta hydroxy compound. If not, if you simply heat it, it is going to lose this water molecule to give alpha beta unsaturated aldehydes. Alpha beta unsaturated aldehydes are very important synthetic organic intermediates. Yes, students. So this is how you are going to get alpha beta unsaturated aldehydes. So what is aldol reaction? Aldol reaction is up to this stage, students. So beta hydroxy aldehydes, what we are going to get is known as aldol, and further heating what you are going to get is aldol condensation product. So the names are, this aldol name comes from not from any scientist name. The aldol refers to aldehydes. The product what we are going to get aldehyde, ald, and this is hydroxy compound what we are going to get aldol, alcohol, aldol reaction. Next, name the following compounds according to IUPAC system of nomenclature. Dear students, already you have learned IUPAC nomenclature rules and regulations are what to be followed during the naming any compound, right? So what are the simple principles? Choose the longest chain, first principle, then give the numbering where functional groups should get lower number, then write the name alphabetical. So write the name of substituents in alphabetical order. These are three major principles. Then following aldehydes or ketones, whatever may the compound, it follows the same rules. So based on that principle, so the first compound, it is 4-methyl pentanol. The second one is 6-chloro-4-ethyl hexane 3-one and butene 2-ol, pentane 2,4-diene, 3,3,5-trimethyl hexane 2-one, 3,3-dimethyl butanoic acid, benzene 1,4-dicarbaldehyde. So dicarbaldehyde, you can name it as di, mono, tri, like that. Yes. Next, draw the structures of the following compounds. Based on the names, you can write the structures. So they have given aldehyde, IUPAC names 3-methyl butanol. Always there is a confusion, students. So Al, don't confuse. Wherever you find Al, it is aldehyde. If it is Ol, then it is alcohol. Suppose 3-methyl butanol, then it is going to be CH2 OH. Yes, so then it is known as butanol. Remaining nomenclature will be same. So para nitro propiophenone. So this is propiophenone, students. Propiophenone, and this is para methyl benzaldehyde. This is 4-methyl pent 3-ene 2-one, 4-chloropentane 2-one, 3-bromo 4-phenyl pentanoic acid. Para, this is para dihydroxy, this is para, right? Dihydroxy benzophenone and hex 3-2-ene 4-ionic acid. Ionic acid is alkyne group, students. This stands for ine, alkyne, right? So alkyne group, for alkyne they have given 4-ine. Next, write the IUPAC names of the following ketones and aldehydes. Wherever possible, give also common names. So heptane 2-one, 4-bromo 2-methyl-hexanol, heptanol, and 3-phenyl propane 2-enol, cyclopentane carbaldehyde, diphenylmethanone. So diphenylmethanone, what is common name? Benzophenone. So common name is benzophenone. This is benzophenone. Diphenylmethanone is benzophenone. This is cinnamaldehyde. Common names I am giving, students. Cinnamaldehyde, this is benzophenone, and it is cyclopentyl carbaldehyde, and this is, yes, so these are very important. Cinnamaldehyde, benzophenone, common names. Draw structures of the following derivatives. The 2,4-dinitrophenylhydrazone of benzaldehyde. So benzaldehyde forms this 2,4-DNP derivative where benzaldehyde presence can be identified by this 2,4-DNP. This is 2,4-dinitrophenylhydrazine derivative, which is known as hydrazone. 2,4-DNP is 2,4-dinitrophenylhydrazine, forms 2,4-dinitrophenylhydrazone derivative of benzaldehyde or aldehyde or ketone. So this is what is this? Hydroxyamine is, what I said, it is oxime. What is this? It is aldehyde acetal. This is acetal. This is semicarbazone. This is ketol, and this is acetal. Yes. So based on names, they have given structures. I am explaining, students. So this is ketol. This is acetal. This is semicarbazone. Oxime. 2,4-DNP derivative. It is acetal. Right? Like this. Predict the products formed when cyclohexane carbaldehyde reacts with following reagents. So the starting material is given, cyclohexane carbaldehyde. Let us take cyclohexane carbaldehyde. What is the starting material? So this is cyclohexane carbaldehyde. Let me write here itself. This is cyclohexane carbaldehyde. When I treat it with phenyl magnesium bromide, so this phenyl is carbanion. So carbanion adds to carbonyl compound, nucleophilic addition takes place. Grignard reaction is an example of nucleophilic addition reaction, where this goes up and takes proton to form this hydroxyphenyl compound, right? So next it is, if I treat it with Tollens reagent is ammonical silver nitrate solution is known as Tollens reagent. Tollens reagent oxidizes aldehydes to acid salts of acid. So silver salt you are going to get. If you want, you can write it as silver salt of silver mirror test it is going to give. So silver salt, this aldehyde forms oxidized compound, it is silver salt. Then semi-carbazide and weak acid. So to move the reaction we use weak acid. Don't confuse, during the amine derivatives we use H plus ions to mediate the reaction. Weak acid is going to catalyze the reaction. So semi-carbazide, dear students, in first slide I have explained semi-carbazide. How to write? Semi-carbazide forms this side. So this nitrogen is going to form semi-carbazide. And excess ethanol and acid. Excess ethanol, what is this? Aldehyde forms acetal. It is going to form acetal. And zinc amalgam and dilute hydrochloric acid. Zinc amalgam dilute hydrochloric acid. What is the name reaction? HCl, hydrochloric acid, HCl. Whenever you see HCl, Clemmensen reduction, acidic medium. Clemmensen reduction is the reduction of carbonyl compounds to alkanes or saturated compounds. So reduced compound you are going to get. This is the product. Next, which of the following compounds would undergo aldol condensation? So aldol condensation, what is the requirement? The compound should have at least one alpha hydrogen, which the Cannizzaro reaction. So the Cannizzaro reaction is where there is no alpha hydrogen, that compounds easily undergoes Cannizzaro reaction, and which neither. Write the structures of the expected products of aldol condensation and Cannizzaro reaction. If I take methanol, so is it going to have alpha hydrogen? No alpha hydrogen. So methanol, let me write the structure. This is methanol. It is carbonyl compound. So formaldehyde is nothing but methanol. So is it going to undergo aldol reaction? No, it undergoes Cannizzaro reaction. Yes students, so Cannizzaro reaction, it is going to form formaldehyde, formic acid, oxidation of aldehyde takes place, formic acid plus methanol, it is going to form methanol. So it is self oxidation and reduction, it is going to form methanol. It is alcohol. Alcohol is a reduced compound or product from of aldehydes, right? So formaldehyde upon Cannizzaro reaction gives formic acid and methanol. So first one is going to form Cannizzaro reaction, 2-methyl pentanal. 2-methyl pentanal, let us write 2-methyl pentanal. 1 2 3 4 5 pentanal. So no doubt 2-methyl, let us write 2-methyl. What is it? 2-methyl group. So is there any chance? Yes, it is having alpha hydrogen, so it can undergo aldol reaction. Benzaldehyde, benzaldehyde is not going to have, it is phenyl group here, it is not going to have alpha hydrogen, so benzaldehyde undergoes Cannizzaro reaction. Benzophenone, benzophenone, just now what I said, benzophenone is the compound. This is, there is any alpha hydrogen? Benzyl, benzophenone, benzyl, benzylic acid, it is going to form benzylic acid. Yes, so 4, sorry, it is not benzyl. So benzophenone is not going to undergo this aldol or Cannizzaro reaction. So this is not benzyl students, I am sorry. So benzophenone is not going to undergo any of these two reactions. Cyclohexanone. Cyclohexanone is a ketone. Yes, it is having alpha hydrogen, so it can undergo what is this? Aldol reaction. 1-phenyl propanone. Yes, it is having 1-phenyl propanone can undergo aldol reaction. Phenyl acetaldehyde. Yes, it can undergo aldol reaction. Butane 1-ol. Butane 1-ol is what is this? It is alcohol. Alcohols will not undergo aldol, neither Cannizzaro reaction. 2,2-dimethyl butanol. 2,2-dimethyl butanol. Yes, it can undergo Cannizzaro reaction. This is how you can predict the products based on the structures. How will you convert ethanol into the following compounds? For example, ethanol is nothing but acetaldehyde. IUPAC name of acetaldehyde is ethanol. Right? So when I do the aldol reaction, I am going to get 3-hydroxybutanol. This upon reduction with sodium borohydride, I am going to get dihydroxy 1,3-diol. Then the same acetaldehyde, when I treat it with dilute sodium hydroxide, this is aldol product. Aldol product upon acid hydrolysis, acid heating, it should be heating, it loses water to give butenol. This is aldol condensation product. This is aldol product followed by reduction. Then the same compound, when I do aldol reaction followed by condensation, I am going to get this diene alkene compound, and this aldehyde upon oxidation using Tollens reagent. Yes, so Tollens reagent or failing solution, I am going to oxidize aldehydes. So Tollens reagent is an identification reaction for aldehydes. So Tollens tests ammonical silver nitrate reaction, it gives alcohols. And one more important thing is acids from aldehydes. One more thing is that Tollens reagent is not going to disturb this double bond. This double bond is intact during the oxidation. Next, write structural formulas and names of 4 possible aldol condensation products from propanol and butanol. In each case, indicate which aldehyde acts as nucleophile and which as nucleophile. Dear students, during the lecture I have explained taking this is propanol, this is propionaldehyde, and this side I have taken butanol. Let us write to this, so remaining things will be same. So it is ET. Let me write here ethyl group. So when it undergoes self condensation of these 2 butanols, it is going to form here, let me write CH2, and it is ethyl. So in this self nucleophile and self carbonyl compound going to be accept. So similar way, this is propionaldehyde undergoes aldol condensation to give this aldol product, where it is going to give this alpha beta unsaturated aldehydes. When this in cross aldol reaction takes place between propanol and butanol, it is going to form, this is from aldehyde, where this, in this case, it is going to act as nucleophile. So this nucleophile adds to this carbonyl compound, followed by dehydration, it is going to give this compound. In this case, so let us write ethyl here, right? So this third compound or the third product, the nucleophile is butanol, and this fourth compound, you are going to get 4 compound, students. Cross aldol compounds, you are going to get 4 mixture of 4 compounds. So this, in this case, it is going to act as nucleophile. If the base abstract the proton here, and it is going to form nucleophile, and it attacks here to give this product, where this hydrogen is nothing but, since we have taken aldehyde, that is butyl, it is ethyl. So this is how you are going to get, in crossed aldol reaction, you are going to get the mixture of 4 products. One is self product of each aldehyde, so that is 2. Then cross condensation with one another, there is a 2 chances. So it is going to give 4 mixture of products. So to overcome this type of mixture of products, aldol reaction will be conducted taking one of the aldehyde as no alpha hydrogens. So for example, same aldehyde, if I do with benzaldehyde, I am going to get single product, right? Next, an organic compound with the molecular formula C9H10O forms 2,4-DNP derivative. That means it is a carbonyl compound. X compound is taken, its molecular formula is derived, and it is giving 2,4-DNP test. And it is reduces Tollens reagent. Tollens reagent. It reduces Tollens reagent means it is aldehyde. Reagent and undergoes Cannizzaro reaction. Aldehyde, no alpha hydrogens. Cannizzaro reaction means no alpha hydrogens. It is aldehyde. Alpha, no alpha hydrogen containing product. On vigorous oxidation, it gives 1,2-benzene carboxylic acid. 1,2-benzene dicarboxylic acid. Identify the product. It is very simple, students. So let me write. Okay, let me use this. Vigorous oxidation with KMnO4. Let me write KMnO4. Right. So aldehydes. This is aldehyde. How many carbons are there? It is given C9H10O. Only 7 has come. So 1,2-benzene dicarboxylic acid. 1,2 means, let me write ethyl here. CH2, CH3. So the first criteria, it is going to satisfy number of carbons C9. Yes, 6, 7, 8, 9. H10, hydrogens 10, 5, 6, 7, 8, 9, 10, and oxygen is 1. 2,4-DNP test, yes, it is going to give 2,4-DNP test. Tollens reagent, yes, it is Tollens reagent. Cannizzaro reaction, yes, there is no alpha hydrogen, it is Cannizzaro reaction. Then upon oxidation using KMnO4, it is going to give 1,2-dicarboxylic acid. KMnO4 oxidation, it is going to give dicarboxylic compound, that is 1,2. It is going to give 1,2-dicarboxylic acid like this. Carboxylic acid, aldehyde gives carboxylic acid, and it is also going to, ethyl benzene is also going to give carboxylic acid. Yes, so it is nothing but 1,2-dicarboxylic acid is nothing but phthalic acid. It is going to give phthalic acid. So the same thing, ethyl benzaldehyde, right, students? So ethyl benzaldehyde is the product. Next, an organic compound molecular formula C8H16O2 was hydrolyzed with dilute sulfuric acid to give a carboxylic acid. Yes, hydrolyzed with dilute sulfuric and an alcohol. Oxidation of C with chromic acid produced B. C on dehydration gives but1ene. Write equations for the reactions involved. Yes, students, let us write an equation. So the molecular formula C8H16O2. What is the product A? It was hydrolyzed with dilute sulfuric acid to give carboxylic acid and an alcohol C. So carboxylic acid, this is 1, 2, 3, 4. Butanoic acid plus alcohol. Esterification takes place in presence of dilute acid to give this ester. This ester, what they are doing on dehydration gives butene. So this is alcohol, on dehydration is going to give butene, where this water goes off, this hydroxy and hydrogen goes off, butene. One butene we are going to get, and with chromic acid produced B. Yes, if I do this alcohol oxidation with chromic acid, what is the reaction? Jones reaction. It is going to give this butanoic acid. The reactions involved, dear students. So they have taken ester, upon hydrolysis gives acid and alcohol. This alcohol upon dehydration gives alkene. and upon oxidation gives carboxylic acid. That is what. And this carboxylic acid, Jones reaction carboxylic acid mechanism detailedly I explained during the aldehydes and ketones, this carboxylic acid chapter. Please go through that carboxylic acid link. Next, arrange the following compounds in increasing order of their property as indicated. So acetaldehyde, acetone, ditertiary ketone, methyl tertiary ketone, reactivity towards hydrogen cyanide. During the first slide, what I said, aldehydes reacts very fast with hydrogen cyanide. So acetone is a ketone, tertiary ketone is a ketone, and methyl tertiary is a ketone. So which is going to form very easily? Acetaldehyde. So acetaldehyde, because aldehydes easily allows approach of this hydrogen cyanide, followed by acetone, followed by methyl tertiary followed by ditertiary ketone, right? So this is acid, alpha bromo acetic acid, alpha bromo acid. This is beta bromo acid. This is acid, and this is also acid. Acid strength. Dear students, alpha halogen acids are more strong because substituent effect is going to affect the acidic strength. So among these, the first more strong acid you have to choose. So alpha more strong acid is alpha bromo acid. Alpha bromo, what is this? 1, 2, 3, 4 butanoic acid. 2 bromo butanoic acid going to be the strong acid this side. Then followed by beta bromo, followed by butanoic acid, followed by side chain or methyl group. Methyl group, since it is plus I affecting group, it reduces the acidity. So the least acidic compound is going to be this methyl propionic acid. When it comes to benzoic acid, 4 nitrobenzoic acid, 3,4 dinitrobenzoic acid, and 4 methoxybenzoic acid. So what is the least? 4 methoxybenzoic acid is going to be the least as acid, and 3,4 dinitrobenzoic acid is going to be the strong acid, because electron withdrawing groups increases the acidity of carboxylic acids. So 3,4 dinitrobenzoic acid strong, then 4 nitrobenzoic acid, then benzoic acid, then 4 methoxybenzoic acid. 4 methoxybenzoic acid is weak acid because methoxy group is electron donating group. Gives simple chemical test to distinguish between the following pairs of compounds. Dear students, this answer is not given in your textbook. So what is there? Propanol and propanone. This is aldehyde and ketone. What is the test available for the differentiation of ketones with aldehydes? Is Tollens reagent and Fehling solution. These are two tests where you can identify aldehydes from ketones. Acetophenone, benzophenone. Acetophenone is, this is a structure, students. So acetophenone is having methyl ketone. Methyl ketones can be identified by haloform test or iodoform test, whereas benzophenone, so this side it is benzene ring. This side, if it is benzene ring, it is known as benzophenone. Benzophenone is not going to give haloform test. And phenol and benzoic acid. Phenol and benzoic acid can be separated very easily just by treating with weak base like sodium bicarbonate. So the mixture, if you treat it with sodium bicarbonate will form the salt with benzoic acid, whereas phenols will not form sodium bicarbonate salts. Yes? Benzoic acid and ethyl benzoate. Benzoic acid forms salt with sodium bicarbonate, whereas this ethyl benzoate, it is an ester, it is not going to form any salts or further reactions. So pentane 2-one, pentane 3-one. 2-one, it is methyl ketone. Yes, so methyl ketones gives haloform test. 3-one, it is going to be here. So 3-one is not going to give haloform test. Benzaldehyde and acetophenone. Benzaldehyde and acetophenone. So what is the reaction? It can be identified by this Tollens reaction, aldehydes gives Tollens reaction, whereas ketones will not give. This is estophenone students, this is estophenone, will not give Tollens reaction. Ethanol and propanol. Ethanol, it is going to give haloform test, right? Ethanol is nothing but estaldehyde. Propanol, it is one more carbon extra, it is not going to give haloform test. This is how you can identify ethanol from propanol. Next, how will you prepare the following compounds from benzene? Dear students, this is very important with respect to all level of chemistry students, whether you are at 10+2 level or 10+2+3 level or PG level or PhD level, right? So preparation of these compounds from benzene, and this question you may get in lot of exams or lot of interviews. So wherever you attend interview, they may ask you how to prepare these compounds from benzene. Write simple equation, methyl benzoate. So if I ask how will you prepare methyl benzoate from benzene, metanitrobenzoic acid, para-nitrobenzoic acid, phenylacetic acid, para-nitrobenzoaldehyde. So they will give benzene and they will ask you to prepare these compounds. So these are very simple basic reaction students. So take benzene and do bromination. So bromination, if I do in presence of bromine and ferric bromide, it is going to be halogenation, aromatic electrophilic halogenation takes place to give bromobenzene. This bromobenzene has to be made into phenyl magnesium bromide by Grignard reaction or treating with magnesium in dry ether to give phenyl magnesium bromide. This phenyl magnesium bromide, upon addition to carbon dioxide is dry ice, gives carboxylic acid, that is nothing but benzoic acid. Benzoic acid, when I treat it with ethanol, I am going to get ester of benzoic acid, that is methyl ester, which is nothing but methyl benzoate. So how many steps? 1, 2, 3 and 4 steps. You are going to make methyl benzoate from benzene in 4 steps, right? And metanitrobenzoic acid, yes, we have prepared same as here, we have prepared benzoic acid. This benzoic acid, when I do nitration, it is going to form meta position. Benzoic acids are meta directing groups, meta nitrobenzoic acid. Dear students, don't write taking like this. Nitrobenzene will not undergo carboxylation. Yes, meta position. Nitrobenzene, if you want to make formylation, Gutterman formylation or any Friedel-Crafts reaction type reactions, it is not going to give this compound. Yes. So the best way is from benzoic acid to metanitrobenzoic acid. Then what else? They asked para-nitrobenzoic acid. Para-nitrobenzoic acid, yes, you can prepare from. So take benzene and do Friedel-Crafts alkylation to give toluene. Toluene upon nitration gives a mixture of ortho and para-nitrobenzoic toluenes. So take para-nitro toluene. This para-nitrobenzene upon oxidation using K-4 is going to give para-nitrobenzoic acid. Yes, if I use direct benzene to nitration, benzoic acid to nitration, it is going to metanitro, right? But we are in need of para-nitrobenzoic acid. That is why we are going to use methyl group, and then after getting nitro group, we are going to oxidize this and benzene to phenylacetic acid. Phenylacetic acid, yes, do the toluene, make toluene same as like this. This toluene, when I do bromination, N-bromosuccinimide, it is not taught to you students. N-bromosuccinimide is a reagent where it undergoes benzylic bromination or allylic bromination. So N-bromosuccinimide in presence of light and use some free radical initiator. Yes, free radical initiator, peroxide initiator you have to use. It undergoes benzylic bromination to give benzyl bromide. This benzyl bromide upon reaction with potassium cyanide, it is going to form phenyl benzyl cyanide. This benzyl cyanide hydrolysis or oxidation in presence of acid is going to give acid, carboxylic acid. It is nothing but phenyl acid. So these conversions are very, very important, students. Please write down somewhere if you want how to make these conversions starting from benzene, right? So when it comes to para-nitrobenzaldehyde, so mild oxidation you have to do. Yes, we have prepared this para-nitrotoluene, para-nitromethyl benzene, and here if I do KMnO4 oxidation, I am going to get acid. So what I have to do? I have to do mild oxidation, that is Ettard reaction. I have explained the mechanism also. Ettard reaction, please go through the video if you want the detailed mechanism. Ettard reaction. So this chromyl chloride oxidizes methyl benzenes to aldehydes to give benzaldehyde, or the other is chromium trioxide in presence of acetic anhydride. You can oxidize toluene to benzaldehyde. However, this chromium trioxide reagent is going to undergo some over oxidation to give benzoic acid. Ettard reaction is best. Then what is the problem with Ettard reaction? Ettard reaction is chromyl chloride is little bit costly reagent, right? You can choose whichever is suitable. Next, how will you bring about the following conversions in not more than 2 steps? Dear students, same. So this is also very, very important. 2 steps. It is a limitation. Ethanol, propanone to propene. So propanone is acetone. Reduction gives isopropyl alcohol. This isopropyl alcohol, upon treating with strong or concentrated sulfuric acid, undergoes dehydration, give propene. Yes, benzoic acid to benzaldehyde. How will you do? So Rosenmund reduction, where benzoic acid upon reaction with thionyl chloride gives benzyl chloride. Benzyl chloride in presence of palladium carbon hydrogenation in presence of barium sulfate. What is barium sulfate? Why we are using barium sulfate? Is going to act as poison. It stops at aldehyde stage, otherwise it is going to give benzyl alcohol. So this reduction is known as Rosenmund reduction. So Rosenmund reaction you can prepare from benzoic acid to benzaldehyde by Rosenmund reduction. Then ethanol to 3-hydroxybutanol. Ethanol and copper oxidation at 350 degrees centigrade. Alcohol vapors upon passing copper tube forms aldehydes. During preparation of aldehydes I explained, right? So copper tube is going to give benzaldehyde, this acetaldehyde. Acetaldehyde upon aldol reaction you are going to get beta hydroxy this aldehyde. Then further what they have asked, benzene to metanitroacetophenone. So first make acetophenone, students. Acetophenone upon nitration gives metanitroacetophenone. Ketones or aldehydes meta-directing groups. So acetophenone upon electrophilic nitration using nitric acid and concentrated sulfuric acid undergoes nitration to give metanitrobenzoic acid, metanitroacetophenone. Dear students, don't follow this route. So nitrobenzene, you may write this way, nitrobenzene and acetyl chloride, you may write this, but it is not going to work out. Acetyl chloride, free electron of acylation I am going to say. So acetyl chloride in presence of aluminium chloride. So this is not correct, because nitrobenzenes will not undergo Friedel-Crafts reaction. Nitrobenzene will not undergo Friedel-Crafts reaction. So that is why nitrobenzene can be used as a solvent in Friedel-Crafts reaction. So don't write this way. So make first acetophenone by Friedel-Crafts acylation, taking benzene to give acetophenone. This acetophenone upon nitration gives metanitroacetophenone. Benzaldehyde to benzophenone. Benzaldehyde to benzophenone. How will you do? Upon oxidation, it is going to form carboxylic acid, potassium dichromate, or KMnO4, or Jones reaction. You are going to form benzoic acid. Benzoic acid, when you treat it with calcium carbonate, it is going to form calcium carbonate salt. This calcium carbonate salt, dry distillation, it is going to form benzophenone. Yes. Bromobenzene to 1-phenyl ethanol. This is bromobenzene, Grignard reagent. Then this Grignard reagent, when you treat it with acetaldehyde, it is nothing but nucleophilic addition takes place on this carbonyl carbon to give this hydroxy phenyl ethanol. Then benzaldehyde to 3-phenyl propanol. Benzaldehyde upon aldol reaction gives, aldol condensation gives cinnamaldehyde. This is cinnamaldehyde, students. So cinnamaldehyde, when I do the reduction, it is going to reduce double bond. Ranitidine nickel reduces double bond as well as this aldehyde. If I use sodium borohydride, no, it is not going to reduce double bond. Yes, so this I am going to get 3-phenyl propane 1-ol. Benzaldehyde to alpha hydroxy phenyl acetic acid. So benzaldehyde upon cyanation, hydrocyanation, it is going to give cyano compound. This cyano compound upon oxidation hydrolysis using nitriles upon hydrolysis in presence of acid going to oxidize to carboxylic acid. Benzoic acid to metanitro benzyl alcohol. Benzoic acid, yes, first make nitration to give metanitro benzoic acid. Metanitro benzoic acid upon sulfuric acid treatment, it is going to give benzyl chloride. Benzyl chloride upon reduction with sodium borohydrate, it is going to give benzyl alcohol. Dear students, no. So there is no need to use thionyl chloride, students. Directly benzoic acid So benzoic acid, if I use okay, so if I use LAH, it is going to reduce this nitro group to amine, so LAH is ruled out. Then left over is sodium borohydrate. Sodium borohydrate acid to alcohol, no. So it is the best way is to make this thionyl chloride reaction to make chloride, then do the reduction to alcohol. Next, describe the following. Acetylation. Acetylation is esterification, Cannizzaro reaction, cross-aldol condensation, decarboxylation. So acetylation is when I take acetyl chloride and do acetylation on carboxylic acid or alcohol, it is going to give in presence of pyridine as a base, I am going to get ethyl acetate. Ethyl acetate is one of the example for acetylation reaction. Then Cannizzaro reaction, students. So Cannizzaro reaction in presence of strong, Cannizzaro reaction will be Cannizzaro reaction is the self-oxidation and reduction reaction of aldehydes having no alpha hydrogen. Aldehydes without no alpha hydrogen. Dear students, methanol, this is methanol or formaldehyde. The carbon, there is no extra carbon, there is no other carbon, so this hydrogen is not alpha hydrogen, students, right? So the alpha hydrogen, if it is having this methyl group, that methyl group hydrogens are known as alpha hydrogen. This is not alpha hydrogen. So the carbonyl compounds are aldehydes having no alpha hydrogen in presence of strong base, concentrated base undergoes Cannizzaro reaction to give oxidized product, that is formic acid in this case, and reduced product, that is alcohol. This mechanism is explained in detail strength. So what is happening in Cannizzaro reaction? Similar to aldol reaction. So the first step is it is going to attack this hydroxy, is going to act as nucleophile. There is no alpha hydrogen, so it is not going to abstract that alpha hydrogen. So it directly adds to carbonyl compound. The first step is addition of hydroxy to carbonyl carbon to give this oxide ion. Oxide ion takes up another oxide ion. This oxide ion adds to this another aldehyde, where losing this hydrogen to give a carboxylic acid, and this carboxylic acid takes up proton from other oxide ion to give sodium salt of this and alcohol reduced product. This is how Cannizzaro reaction gives oxidized compound of acid and reduced product of alcohol. Cross aldol condensation. Cross aldol condensation, yes, what I said, cross aldol condensation. For example, if I take benzaldehyde and benzoic acid, which is not having no alpha hydrogen, it is going to give, this is cross. Why cross aldol? If I do only with same aldehyde, it is known as aldol reaction. So if I do with taking two different aldehydes, it is known as cross aldol reaction. So I am going to get cinnamaldehyde, and one of these two aldehydes, it is no alpha hydrogen, so that is why I am going to get one product, major as one product. Whereas if I use this type of two different aldehydes, I am going to get mixture of 4 products. So aldol reaction usually preferred with this type of compounds, where there is no one of the substrate is without no alpha hydrogens. Next, decarboxylation. Decarboxylation, carboxylic acids in presence of soda lime, that is mixture of sodium hydroxide and calcium oxide in 3:1 ratio, is known as soda lime. In presence of soda lime, upon heating, it is going to undergo decarboxylation to lose carbon dioxide to give alkanes. Yes, student. So aryl carboxylic acid, even simple heating without this soda lime also undergoes decarboxylation, but at high temperatures. This is how decarboxylation takes place. Kolb's electrolysis also is one of the methods of decarboxylation, where during this Kolb's decarboxylation, in this case, if I take, suppose this is a acetic acid, for example CH3, I am going to get methane gas. Here it is methyl or methane gas. But in the Kolb's electrolysis, the same acetic acid, if I do electrolysis, I am going to get ethane gas, where it is undergoing self-coupled product to give alkane of ethane. So this is also one of the examples for decarboxylation. Next, complete each synthesis by giving missing starting materials, reagent or products. It is very simple, students. So this ethyl benzene upon oxidation KMnO4 KOH heat. This mechanism also I have explained during aldehydes and ketones reaction, students. Carboxylic acids chapter, right? So whatever may be the chain, it is going to break here to give benzoic acid, right? So thionyl chloride, what is going to happen? Thionyl chloride, carboxylic acid adds this chlorine in presence of thionyl chloride to give acid chlorides. So carboxylic acid, phthalic acid undergoes reaction with thionyl chloride to give phthalyl chloride, and this is potassium benzoate. You can write this potassium benzoate, or you can write acid also. So both are going to be correct, but since it is in basic medium, they didn't give in second step, that is use of acid. So you have to write potassium salt of benzoic acid. Oxidation takes place. Yes, KMnO4 oxidation takes place. This is semicarbazone. Add this side, semicarbazide, add this side. So add this side, imine formation. So this is benzene to benzophenone. Already we have seen some examples. So simple benzylation, take benzyl chloride, free radical of acylation in presence of what is the reagent? Aluminum chloride, right? Benzylation takes place to benzophenone, and this is semicarbazole in presence of H plus. It is given or not given, though it is not given, even with simple addition also it undergoes semicarbazole formation. Next, so what is this ammonical silver nitrate solution? It is Tollens reagent. Tollens reagent in your textbook it is written in a wrong way. So the product was given, this is aromatization and all. No students, Tollens reagent is not going to react with this ketone. So Tollens reagent will make this aldehyde to acid of silver salt, So this answer is printed wrongly, so please correct it. And sodium cyanide HCl, cyanation takes place. So to confuse you, they have given HCl, so don't worry, it is going to add to this sodium. Hydrocyanation is going to take place. Hydrocyanation, since it is having sodium salt, it is going to form salt, and upon addition of HCl it is going to free up. So that is how it is going to form alcohol. Yes, so this is, so simply you can write it as silver also. So this answer please correct in your textbook, students. So write down, this is the correct answer. Next, benzaldehyde, propionaldehyde, dilute NaOH. Just now I have explained cross aldol product, and this is very very important, students. Ketone and ester, chemoselective reduction. So there is ketone group and ester group. When I use sodium borohydride, which group is going to be reduced? So sodium borohydride chemoselectively reduces carbonyl compounds to alcohol. This ester is not going to be reduced by sodium borohydride. If I use LaH, it is going to reduce both. So that is why they have given specific reagent. So what is going to happen? Yes, this is dilute NaOH aldol reaction followed by heating. So aldol condensation product as single product. So to overcome other side products, they have given other products, but in this case other products are not going to be formed. It is going to be the major product, and this is reduction of carbonyl compound takes place but not ester. So to confuse you, they have given H plus. This H plus is to work up the sodium borohydride reduction step, where sodium borohydride salt has to be hydrolyzed using H plus. Mild acid or even water also is enough, right? So this ester, if they have given this heating, then this ester also should have undergo hydrolysis, but it is not going to hydrolyze this ester simple H plus ions, right? Heating is required. Next, so alcohols upon oxidation, Jones oxidation, secondary alcohols gives ketones, primary alcohols gives acids, right? So this upon ozonolysis is going to give aldehyde, and this ozone, from where will you get this ozone? So if I write this side also same cyclohexene, it is going to form this cyclohexanone. So this is the chromium trioxide reaction where Jones reaction is used, and this is this is not ozonolysis. So you have to do hydroboration. Hydroboration is anti-Markovnikov's addition, where this boron is going to add to this BH2 here, and here it is hydrogen, and this borylation upon treatment with hydrogen peroxide, this boron compound hydrogen peroxide in presence of base gives this aldehyde, right? So alcohol, you are going to get alcohol. This alcohol, whatever the alcohol you are going to get upon treatment with PCC, pyridinium chlorochromate, this is the reagent of Collins reagent. So upon Collins use of Collins reagent, it is going to oxidize alcohol to aldehyde stage only. This Collins reagent is not going to oxidize further. Right. Next, this is ozonolysis. This alkene upon ozonolysis you are going to get ketone. Next, give plausible explanation for each of the following. Cyclohexanone forms cyanohydrin in good yield, but 2,2,6-trimethyl cyclohexanone does not. It is the first slide itself I explained. So this side it is 2 hydrogens, though it is. So cyanide group wants to attack onto this, or if it wants to attack this carbon which is there, this side, two sides it is, though it is methylene groups, the substituent is only hydrogen, it easily attacks onto this carbonyl compound, whereas this 2,2,6-triethyl cyclohexanone does not. Because of these methyl groups, this carbonyl carbon is hindered. This carbonyl carbon is hindered. So approach of this nucleophile to onto this carbon. So see, this much big route it is not going to undergo. However, if you want to force, yes, it can, but it requires harsh reaction conditions. Give plausible explanation for each of the following. There are 2 amine groups in semicarbazide. Again they are asking. However, only one is involved in the formation of semicarbazone. Just now what I explained. So this lone pair is resonantly stabilized. So this is going to be inactive, or it is not going to form imine. So this amine group is going to be free. So this amine is going to form semicarbazone. During the preparation of esters from carboxylic acids and an alcohol in presence of an acid catalyst, the water or the ester should be removed as soon as it is formed. During the explanation of this carboxylic acid chapter also I have said. So you have to use the Dean-Stark apparatus. There is an apparatus known as Dean-Stark apparatus which removes water, whatever the water is formed during the reaction. If this removal of water is not possible, then you can remove, if it is possible, of your ester. Then what happens if not removed? What is happening, students? So it is forming carboxylic acid is reacting with alcohol as a nucleophile to give this ester. So ester, if you do not remove this water, back reaction, what is going to happen? Same back reaction, hydrolysis, ester hydrolysis is going to take place. Ester hydrolysis in presence of water takes place to give back your acid and alcohol. Yes. So this esterification reaction using acid and alcohol in presence of acid catalyst is not quantitative reaction, right? So that is why we will follow different routes where you can use some other reagent or mixed inhibited method or other methods for preparation of esters, where first make it as acid chloride, then treat it with this ester, like that. Other methods are there. Or DCC, use of dicyclohexyl carbodiamide. Some esterification reagents are there, students. DCC, use of DCC, it easily dehydrates and gives quantitative esters, like that. An organic compound containing 69.77% of carbon, 11.63% of hydrogen, and remaining will be oxygen. The molecular mass of the compound is 86. Yes, it does not reduce Tollens reagent. That means it is not going to be the aldehyde. It may be ketone or ester, but forms an addition compound with sodium hydrogen sulfide. So hydrogen sulfide, yes, it forms hydrogen sulfide with ketones also. Iodoform. So iodoform test it is giving means, so simply write down methyl is going to be there. Iodoform test. So ketone, till now it is satisfied. This is methyl ketone. On vigorous oxidation, it gives ethanoic and propionic acid. Vigorous oxidation, it gives ethanoic and propanoic acid. Ethanoic acid and propanoic acid. This is ethanoic acid. So if I break here, it is going to form CH3COOH. So it is propanoic acid. 1, 2, 3. So ethanoic acid, if I break here, it is going to vigorous oxidation, use of KMnO4, it can break here and here. Yes, I have explained giving numbering also. If it takes here and here like that, please go through that video, that link what I have given. Yes, so oxidation of carbonyl compounds. So this KMnO4 oxidation is going to give. So what is there? So let us count on the carbons and hydrogens and oxygen. 1, 2, 3, 4 carbon, C4, 3, 2, 3, 4, 5, 6, 7, 8. 8 hydrogens, 1 oxygen. So 12 4 ja 48 and 8. Oxygen is 16. Isn't it? Is it man? Propanoic acid. One more carbon. One more carbon. So C5 and here 10. Right? 3, 4, 5, 6, 7, 8, 9, 10. Right? It is 60 plus 10, 70 plus 16, 86. So this is 1, 2, 3, 4, 5. 2-pentanone is the starting material. How? So you can calculate like this. So this is the way you can calculate 100%, and this is tedious. Anyhow, this is the best method to follow, right? So take 100 and remove this. You are going to get 18.6% of oxygen, and when you substitute this 12, 7, this is the way you have to do, and you are going to get this, the product. And what they have given, so when it reacted with sodium bisulfite, you are going to get this sodium salt, sulfonate salt, and this upon reaction with sodium hydroxide, it is going to give haloform reaction, right? In presence of iodine, it is going to form haloform test, and ester, this ketone upon oxidation using potassium dichromate or KMnO4, it is going to give acetic acid and propionic acid. This is how the unknown compound can be identified. Although phenoxide ion has more number of resonating structures than carboxylate ion, carboxylic acid is a stronger acid than phenol. Why? So carboxylic acids are strong acids than phenols, because phenol is having ring resonance structures, whereas carboxylic acid is the carbon which is bearing this hydroxy group is itself is resonantly stabilized because of 2 oxygen groups. So this is why carboxylic acid is more stronger than phenoxide ion. That is why phenol will not form salt with sodium carbonate and sodium bicarbonate like weak bases, whereas carboxylic acid forms salt with sodium bicarbonate and sodium carbonate along with sodium hydroxide, whereas phenols forms salt with sodium hydroxide and carboxylic acids also form salt with sodium hydroxide. Phenols will not form salts with weak bases like sodium bicarbonate or sodium carbonate. And if you take overall products or compounds of organic compounds, what is the acidity order? So for your convenience, I have given pKa value HCl. Inorganic acids are strong acids, friends. So just take out these inorganic acids. When it comes to organic acids, one of the strongest acids of organic acids is trifluoroacetic acid. This trifluoroacetic acid pK is 0.23. Overall acidity order is carboxylic acids followed by phenols, phenols pKa value is going to be about 10, followed by water. Water is not is going to be not considered as acid or base in this case. So followed by alcohols, followed by alkynes. So the question is, why phenol is weak acid then carboxylic acid? The answer is carboxylic acid is resonantly stabilized oxygens on carboxylate ion. That is why this carboxylate ion is more stable than phenoxide ion, right? So this is how you can write the answers. Thank you, students. Thank you for watching this video. Please subscribe my channel Venus Academy if you are not yet subscribed, and don't forget to click on like button and bell button. We will meet again with new chapter, amines. Till then, bye. Arigato gozaimasu. Thank you, students. Bye.